Today, I'm going to show you something that you have never seen before. I'm going to show you how to come up with the quadratic formula, but we are going to start with x is equal to rei theta, and we'll use the Euler's formula, which is what I have on my back. Here we go. First, we will plug in this into all the x's, so we have a times rei theta squared plus b times rei theta plus c is equal to 0. And then we will fix this a little bit. That's ar squared. And we can actually multiply the exponents because of the Morav's theorem. So we have I will put I and then 2 theta like so, plus brei theta plus c is equal to 0. Okay, and then I'm just going to be using the Euler's formula to take off this and that. And remember CIS, cosine and then I and then sine. So that's AR squared times cosine of the angle plus I times sine of the angle. And then this right here is BR, and we have cosine theta plus I sine theta. And then lastly, we have the plus C. It's equal to 0. Now, if you take a look right here, we have some real parts and also some imaginary parts. So that's kind of organized step. So first, this times that, AR squared cosine 2 theta. This times this is also going to be real. And then of course C. And of course A, B, C are real numbers to begin with. Anyways, that's the real part. And then we add I times this times that, and we have AR squared sine 2 theta, and then this times that plus BR sine theta, and all that equals 0. Now, what exactly are we trying to achieve though? Let's go back to here a little bit. X is equal to rei theta. If I use Euler's formula to break this apart, this is the same as saying we have, let's write it down here, R. This is cosine theta plus I sine theta, and let's distribute the R. So we have R cosine theta plus I R sine theta. So the goal is to figure out what R cosine theta is, as well as R sine theta is. Then together, we should end up with the formula for X. And our best bet is to look at this. Remember, if this is equal to 0, the real part has to be 0, and the imaginary part also has to be 0. So we have two conditions. I'm just going to label this as the first one, and this right here as the second one. And I need more space. So I'll put this equals 0, and I'll also put this equals 0. Okay, here we have these two conditions, and to get this and that, let me start with the second equation. Right here we have sine of 2 theta. Let's just use the double angle identity for it. So here we have AR squared times 2 sine theta cosine theta, and then plus BR sine theta. That's equal to 0. And we can factor out an R and also a sine theta. So let's do that. And then we will have 2A, one more R, and then cosine theta, and then plus just B right here. So now we have three factors, R, sine theta, and this. They are multiplying and we get 0. Firstly, if R is equal to 0, then X is just equal to 0, which is possible if C is 0. So boring, I'm not going to consider that. And then if sine theta is equal to 0, that means this part will be 0. So that means X is just going to be real, which is like the real quadratic formula. So I'm not going to consider this being 0 either. But anyways, I'll just say these are the boring cases. But anyways, this is the interesting part. We want this equal 0. Now have a look. I want to isolate R times cosine theta. So put B to the other side and divide both sides by 2A. Ladies and gentlemen, R cosine theta equals negative b over 2a. Look at that. Isn't that the vertex formula of a parabola? Yes, it is. And this right here happens to be like the first part of our quadratic formula as well. So let's go ahead and write it down right away. So keep in mind, this is equal to that. Now, we want to find out what our sine theta is. Okay, let's have a look. Let me divide both sides by r first. You will see. I think it's slightly easier if you do it like this. We can see that cosine theta is equal to negative b over 2a times r. And then we know the relationship between cosine and sine. To get sine theta, that's just plus or minus square root of 1 minus cosine squared. The Pythagorean identity. And truth be told, this right here is kind of like the part that where you have to put a plus minus and then take the square roots both sides, all that stuff. It's right here. Anyways, I'll put this right here. So we get sine theta equals plus or minus square root of 1 minus negative b over 2ar square. And of course, that's plus or minus square root of 1 minus positive b squared over 4a squared r squared. So that's how sine theta looks like. But I also need the r. What can we do? Well, we haven't used the first equation yet. Let's go ahead and do that. So here, we have cosine of 2 theta. But we have a double angle identity for that as well. So right here, I'll use this version. 2 cosine squared theta minus 1. Because I'm trying to figure out r sine theta, and I have this, I know sine theta is this, but if I just have cosine theta, it's much easier. So use this version, and then we have the rest. Okay, and then distribute 2a, and then I'm going to write this as r cosine theta squared, and then this times that, so it's minus ar squared, and then plus b, and then r cosine theta, and then plus c is equal to 0. R cosine theta is this, so that's 2a, and then we have negative b over 2a squared minus ar squared plus b times negative b over 2a, and then plus c equals 0. Now check this out. This right here is b squared over 4a squared, and then multiplied by 2a. So together, that's b squared over 2a. This right here is also b squared over 2a, but positive times negative, so that's a minus. So in fact, this and that disappear. It's just 0. Okay, then we see we have this plus that is equal to 0. I want to isolate r squared first. We can see that r squared, put that to the other side, divide both sides by a, so it's c over a. And then right here, you can just take the square roots both sides, put a plus or minus, so r is also going to be plus or minus square root of c over a. And just a quick note, you could say r is just positive when you have a polar form. It doesn't really matter though, in my opinion. I'm going to just leave it like that. And what we are going to do next is sine theta. We know it's this. It has the r squared, which we know is c over a. And then I also need to find out what r times sine theta is. So have a look. R times sine theta, it's going to be, the r here is this, plus or minus square root of c over a times sine theta, it's this. It's also times plus or minus, and then we have the square root, and then we have 1 minus b squared over 4a squared r squared. But r squared is c over a, so multiply by c over a here. Have a look. This and that cancel, pretty nice. And we can also distribute this inside. So we have First, plus minus times plus minus is just plus minus, because you can have positive times negative, so minus. But anyways, that's just minor, so plus minus. Okay, right here I will just keep the first part for now a little bit, because I want to combine the fractions here. So I need to get the common denominator, which is 4ac. So right here, 4ac. That means this right here should also be 4ac, and then minus b squared. Okay, and then just multiply this in. So this is going to be plus or minus square root, and then c over a times 4ac minus b squared over 4ac. C and C cancel. Ladies and gentlemen, you see that we get plus or minus, take the square root on the top. We have 4ac minus b squared. That's strange, huh? Because it's kind of like backwards, but don't worry. Over square root of 2, square root of 4 is 2. Square root of a squared is just a. So r sine theta, it's actually just this part. So if you take a look right here, this is going to be plus I, and then this whole thing, it's this, which is square root 4ac minus b squared over 2a. Of course, with a plus or minus right here. So ladies and gentlemen, let me just write this down better for you guys. So when we have a quadratic equation in the standard form, we know that x is equal to this, and they have the same denominator. So we can just write negative b. We add, here we have the plus or minus, so I will just put a plus or minus here, and then we have the I, and then square root of 4ac minus b squared. So strange, huh? And then all over the denominator 2a. Yeah, why is this backwards? Don't worry, because what's I? You can look at I as square root of negative 1. Then go ahead and just multiply this to the inside. Don't worry though, we have the plus or minus in the front right here to take care of any like weird situations. Go ahead and just feel free to multiply negative 1 to the inside. So we get x equals negative b plus or minus negative 1 times negative b squared, we get the positive b squared. Negative 1 times 4ac, here is the minus 4ac. And of course, all over 2a. Ladies and gentlemen, this is the quadratic formula. That's it.